Hello and welcome to another episode of On the Floor with Wayne and Rob. I'm Wayne Highlander, National Sales Manager for Bona Adhesives.
And I'm Rob Johnson from Bona Training.
How we doing, Rob?
Real good. How about you?
I'm doing fantastic.
How's your New Year's?
Everything's good, man. I'm excited to start the year off. We got a lot of good things happening, and I've added another member to my team, which I'm super stoked about. And so glad to get him on board.
Well, let's hear a little bit about him.
Yeah, Gene Vincent out of New York, Boston, Philly. He's going to be our adhesive manager in that area. And you ever meet someone that you felt like you've known him your whole life?
Yes.
He's that guy. I
met him yesterday. I did a school with him.
That's right. You did, huh?
I did a school with him. Right.
Mm-hmm. Got a warm smile.
He shoots me an email, and we had a conference call, and I said to all the TMs, hey, if you need this information, just let me know and I'll, send it out to you, the RTC booklet. So I get this email from Gene Vincent. I think that's how you pronounce his name, right?
Vinson.
Yeah.
Yeah, Vincent.
And he's like, yeah, great, Rob. Thanks a lot. It's great. I'd love that, and I said, sure, I'll send it to you. Who are you? That's what I said in my email. Who are you? Yeah. And he goes, actually, I'll meet you tomorrow. I'm the new adhesives guy for the Northeast. So yeah, I did meet him. He spent a couple days with us at the school. Really, really super guy. I think he's going to do great in that territory.
Yeah.
Very personable, friendly. You're right. He's one of those guys you meet that you felt like you've known him all your life. He just came in, blended right in, and
yeah,
he's a great fit. So good luck to Gene and you.
Yeah.
Well, you don't scare him off like the rest of your guys, but
true. And thanks for pointing out that I didn't communicate very well that we got a new guy on board.
I had to get that little.
I knew it. I knew
to get that little one in there. Yeah.
All right, Rob, what are we going to talk about today?
Oh, one of my favorite episodes. The episode with Howard Brickman on the science of wood. I don't know about you, but I could listen to Howard Brickman all day long. He's a great guy to talk to, but then all of a sudden, when you want to start picking somebody's brain about anything to do in the wood floor industry, he's the guy. He just has so much great knowledge, and he explains it in a way that you can understand it. That's one of the other things I love about Howard.
Yeah, he is, and it's funny because I picked John Namba. We each picked one episode we want to go back and revisit. I picked John Namba. We had the week prior, or I don't know, it was a week prior when it was going to air, and you picked him, and two Goliaths in the industry. So I think this is going to be really good. And this is one also, again, that I had to go back and listen to it again because there's so much information on here. You know what I mean? I mean, it's just, he says one sentence and it's like, man, there's so much behind that. And so this is a great one to go back and revisit. And I think it's one of those episodes, if you heard it before, it'll be just like you hearing it for the first time. There's so much information in there. So Rob, stay with me.
I didn't think, when you went back and listened to it, I didn't think you'd like it because it was a lot of Howard talking and
not so much me.
Yeah. Well, I'm glad you picked that ball up. Appreciate that.
Yeah. Well, listen, everybody's got to know their place. All right.
Some of us are on the couch and the other ones are behind the desk.
There you go. Make yourself comfortable. Let's sit back and revisit this interview with Howard Brickman. Let's roll it.
Today we're talking with Howard Brickman about science of wood floors and moisture and how it affects wood flooring and cupping. And Howard is just a wealth of information. And you've been in the trade a long time, as we all have, and there's newer guys getting in the trade. And what are the challenges you seeing? As far as younger guys getting into the trade, maybe, and then getting on job sites and acclimating to wood. It seems like we close these homes are built so fast today. And they're so tight now, so closed up. Does it change the way you approach acclimating your flooring to a job, or maybe we can just talk a little bit about that?
Okay. I think that the industry has the acclimating thing backwards. Okay? And by this I mean most of the wood flooring that's manufactured is already at the right moisture content, unless you're in some wacky place like Denver or Las Vegas or New Orleans or Miami, okay, where you've got very high or very low moisture levels, ambient moisture levels. That's just the environment. For most of the continental U.S., the lower 48 states, the way they make the moisture content that they make the flooring is just about where you want it to be when you install it. So essentially, the first step in acclimating is really about getting the environment correct. And I know also we're obsessed with relative humidity. And in actuality, you open the windows and it's a nice day, the relative humidity is one thing, and on a rainy day, it's another thing, in the winter, it's another thing. And essentially, I think the things we should be focused on are moisture content of the subfloor and moisture content of the flooring. And those are things that you need a proper moisture meter to check. And you need to use that moisture meter until you break it and wear it out. I mean, this isn't museum equipment. This is like your hammer. You're using that moisture meter to really give a thorough examination of the space. So the very first thing you should do before you even deliver the flooring is you should go in and measure the moisture content of the subfloor. That's going to give you a pretty fair idea of the conditions that have existed in the house for the last 30 to 60 days. If the house is dry currently and has been dry for 30 to 60 days, your subfloor is probably going to be right where it needs to be. In the Northeast, we're looking at subfloor moisture content where we really want it less than 11%, somewhere between 8 and 11%. Okay. You get down into the dry, arid places in the U.S. like El Paso, Phoenix, Denver, Las Vegas. You probably want the subfloor to be 6 to 7%. You get into places that are pretty humid, like New Orleans, Galveston, Houston, Miami, Tampa. Those places, you want a moisture content in the subfloor that's probably no more than 12 or 13%. Okay? And so it's not about the relative humidity as much as it is about the equilibrium moisture condition of the two things that are going to be touching one another. That's the bottom of the flooring and the top of the subfloor. And then you don't want anything up under that subfloor that's going to add extra moisture. In other words, you want a building that's, in pretty decent shape. You don't want a crawl space that's got 6 inches of water in it. You don't want a wet basement. You don't want a damp basement. There are building science things about basements and crawl spaces that we kind of do wrong in the wood floor business. And for the most part, we kind of ignore them. So again, a lot of times if there's an ambient excessive moisture condition in the building, being able to check that moisture content with a proper moisture meter, and that's typically an electrical resistance or pin type meter. And those pins need to go into the material about 5/16 of an inch. You don't just touch the pins on the surface. You got to jam them in there. Okay.
Are you talking about insulated pins, Howard? When you're
I don't think it really doesn't matter. The primary use for insulated pins is when the surface of the material you're measuring has water or moisture on it. And so typically insulated pins, their primary usage is in the lumber drying business, where you're out on a air drying yard and maybe it's a dewy morning or it rained the day before and you want to check the moisture content of that lumber outdoors. And so you use an insulated pin so you can get past that moisture, which would give you a false high reading. And so you're pushing those insulated pins into the material so that you can get the interior moisture content. In a house, in the interior of a building, the surfaces shouldn't be wet. Okay. So actually use just a plain steel pin should be plenty good enough for subfloor.
I think the sometimes the general feeling is that you can just drop off the wood for so many days and it prevents the swelling and shrinking of the floor. And I think that's not very accurate, is it?
And not really. One of my favorite sayings is it's not a time thing, it's a moisture content thing. Okay? And so that being said, if the flooring is already at the right moisture content, what is the best case scenario that's going to happen on that job site? It's that you're not going to mess up the flooring, right? That's the very best case scenario. So the critical step in the acclimating process is not worrying about the flooring. It's worrying about the building. It's paying attention to the conditions in the building. Moisture content of the subfloor being the primary condition. That's the biggie. If the moisture content of the subfloor is good and the building is tight, the building is, the windows and doors and chimney and the roof and all that stuff are functioning properly, no wet basement, then essentially you're good to go. Now, occasionally you're working in a high humidity area where the ambient relative humidity on the job is going to be high, for the life of the floor. You're going to need to let the floor pick up some moisture before you install it. And so, but 4 or 5 days, I can tell you from personal experience, it's not going to do anything. It's just going to let the ends swell up a little. Yeah, it's just the ends are going to swell up a little bit. Especially if it's in bundles, because it's only the outside surfaces of a bundle that are exposed. And if the flooring is dead piled in the middle of the room somewhere, where you just have the exposed exterior surfaces, because where all those boards are piled together, there's no air circulating in there. So it's only the ends of the boards and the edges that are exposed to any kind of moisture. It's really not going to do anything.
Okay, so I've not heard the expression before, but I know exactly what you're talking about when you say dead piled. So maybe you can explain the proper way to drop the floor off on a job site.
When we dry lumber, we have to stack it with spaces between the boards. So they use sticks, or they call it sticks or stickers, and they're essentially 3/4 inch thick boards that are placed every 2 feet. And if you see pictures in the wood handbook or any place where you see hardwood lumber or softwood lumber dried, you see lumber stacked on these sticks, and then it's dried by air, and then it's put in a dry kiln, and that's so the air can circulate across the surfaces of the boards. So once the drying is completed and they unstack the lumber, and they're going to store it for a period of time, they unstack the lumber, they pull all the sticks out, and they just pile it together with all of the surfaces tight together, and that's called dead piling it. So when we purchase flooring and it's in bundles or in boxes, those individual pieces of flooring are stacked face to back to face with no spaces in between them. And that's what I would refer to as being dead piled. So essentially, there's no way for air to circulate around all of the surfaces of the individual boards.
I've seen that done so many times, Howard, where the wood is stacked up in one big, huge stack in a corner of a room, and you've got kind of the right idea, but it's really not effective, is it?
It's not really. In fact, it's counterproductive in that because of the structure of the wood cells, um, um, the moisture is gained and lost through the end grain at a factor of 14-1 over the sides of the boards. So what happens if you bring the material into a high humidity environment and it's just the ends that are exposed, those ends will start to swell. And so you'll put the two boards together and the ends might match, but then all of a sudden the floor won't stay straight because the center portion of the boards, 6 or 8 inches away from either end, hasn't swelled as much as the rest of the board. And so initially over a short period of time, that difference might be 1/100 of an inch. But if it sits there for a while under high humidity conditions and their boards are wide, I mean, you could have the ends swelling by 1/16 of an inch, which is a lot. That could make putting a plank floor a nightmare together.
So
I guess the answer would be for something like that, when you're going to acclimate, is to get a true acclimation, you got to break those bundles open and stack them that way.
Yeah, you got to. The best way to acclimate it is to rack the floor, lay the boards out, and let them sit. And in my personal experience, 3 to 4 weeks.
Well, what about engineered floors? A lot of people think that's the answer. Well, it's really super high moisture, whatever. How does that affect an engineered floor differently than a solid?
Well, engineered floor is really intended to be used in higher moisture areas. Okay. And what it does is it takes by using the mutually perpendicular axes of wood, where it shrinks and swells most perpendicular to the long axis of the board. Okay. And if we take the longitudinal axis, the long axis of the board, there's very little shrinking and swelling. There is some, but very low. So essentially,
I'll break that down. I'll break that down to you later, Rob. The axis and longitudinal part. But continue, please, Howard.
Okay. So when we make plywood, for instance, we use the fact that in length the wood doesn't shrink very much, but widthwise it's trying to shrink and swell. So by putting alternating layers, the long axis restrains the cross axis. Okay, the cross grain is restrained by the long grain, and so by layering that up, it takes that normal, fairly substantial shrink and swell that we expect with solid wood. It takes that and it reduces it by 85, 90%, maybe a little bit more. If a piece of wood was going to shrink and swell by 1/8 of an inch, instead it'll be under 1/100 of an inch. So essentially by cross-laminating those, it resists that shrink and swell. And so the great news is that swelling that occurs is so small in the width of the board that it's, as a practical matter, really not meaningful in a multi-level floor. So when we buy a sheet of plywood or Advantech or one of these other panel materials, if you look at the thing that's stamped on the face of the sheet, it says to leave 1/8 of an inch space between every sheet of plywood and Advantech. It says to leave a gap around those sheets of subfloor, and that's because they understand that material is going to shrink and swell depending on the conditions it's exposed to.
What about engineered floors in a really dry climate? Are you worried about?
Oh gosh,
what the
yes.
effects?
Yeah. I have to say,
okay.
It's been a blessing for my consulting business. Okay. Engineered in a dry climate, I'd be out of business. I'd be out of business if it wasn't for that.
Wow.
I mean, it's been a boon for me personally.
And is it checking?
It's everything. It shrinks, it checks, it cups, it splits, depending on the moisture content of the lamellas when it's manufactured.
That's what I'd like to have explained to me is I know what wet cupping is, but what is dry cupping?
Dry cupping is because and it's really only a creature of these fairly recent, and I mean within the last 15, 20 years, where we've taken, instead of, if you remember the old engineered flooring, the old Bruce and modern wood and all those people, they used to make an eighth and an eighth and an eighth, and they glued it together, and it was all oak, and it was all relatively thin layers. So basically it was engineered was plywood, and the plies were fairly thin. And because the plies were thin, they didn't put a lot of stress on one another as they were shrinking and swelling, because they just weren't thick enough to provide any stress. But some genius somewhere decided that we needed to have a thicker wear layer on engineered so it could compete directly with solid. Okay?
I think Wayne had something to do with that.
I don't think so, Wayne. I think he's just pulling your leg.
You think?
I think so. And
Okay.
so when they did that, what they essentially did was they glued a solid board, because those wear layers are 1/4 to 5/16 of an inch thick. Okay. So they glued a solid board onto a piece of plywood. When a piece of engineered that's made that way swells, it's basically wants to crown or become convex on the surface. And because of the strength of the plywood and the strength of the wood, it kind of resists that. Okay. But when it shrinks on the face, it starts to pull up on the edges of the board, because the face is shrinking at a different rate than the plywood to which it's been glued. So if we look at the shrink and swell factors, that they publish in things like the Wood Handbook and other technical things. And by the way, while I mentioned the Wood Handbook, everybody in our business should go to Forest Products Laboratory, and for free, I mean, this is one of the few things you're going to get out of the U.S. government for free, okay? This is like free money. So you go to the Forest Products Laboratory, their website, and you can download the PDF of the Wood Handbook. And it's got more information on wood than you'd ever want to know. I mean, everything from wood anatomy and cell structure right through to pressure treating and biodegradation from all kinds of insects. And it talks about framing lumber, and it's got some great sections on there in shrinking and swelling. It's got a great section on panel products. And it turns out that I'm going to use these numbers because these are the numbers in the Wood Handbook, and they're pretty useful, okay? So if we look at a piece of plywood, the typical shrink and swell across the plywood on both its X and Y axis, as you're looking at the sheet, on its length and its width, it's about 0.5% to go from fiber saturation point all the way down to totally even dry. In other words, to go from being totally saturated with moisture to being totally dry, no moisture at all, totally even dry, would be 0.5%. A piece of plain sawn oak has over the same range of moisture levels from fiber saturation point down to oven dry would be about 8 to 9 to 10%, depending on the species of oak. Okay, and so basically, if we let's compare 10% to 0.5%. That's 20 times larger. Okay, so a piece of plain sawn white oak, for instance, which would have a typical shrink factor of 10%, is on a piece of plywood which has a shrink factor of 0.5%. That's wanting to change dimension at 20 times greater factor than the plywood underneath it. And so that's why you get that shape change. Or in the wintertime, as the face is drying, that exposed solid lamella face is drying, it's actually shrinking, and then as it's shrinking, it's actually bending the plywood underneath it. And so that's what dry cupping is, right?
Wow. And that's how you get dry cupping. All right.
Yeah. And it's a creature of the winter. And it's typically it's a creature of the winter, or it's a creature of a super dry climate, like you'd get in the West.
But it
in
also
the arid
sounds like
West.
it's more of a creature of engineered floors and not solid floors.
Yeah, it is.
Okay.
It is. It's definitely a creature engineered, and let's call it a characteristic. It's actually.
No, I like creature. I like the word creature.
Creature's good.
Howard, I was on a job one time in California, and it was really, really hot out. You know, we acclimated. Actually, it would have been acclimated for a long time, and we didn't get back to sand it for 3 or 4 weeks later. And we went through the sanding process, and the garage door was left open to the house while we were working, and it was a hot, dry wind that came through there, and that slightly cupped the floor. And it's the first time I had ever seen it, and the floor was flat. I mean, when we sanded, I think we were most of the way through the sanding process, but that garage door was left open, and the house was left open, and the wind was coming from that direction, and it was a hot, as I said, dry wind, and that actually cupped the floor.
Yeah, and essentially, cupping isn't about moisture from underneath. It's really about on a solid piece. It's about an asymmetry, or a difference in moisture content between the two surfaces, between the face and the back. So we can look at it in 2 ways. We can say that the underside is picking up moisture or at a higher moisture content, or conversely, we can say that the face is at a lower moisture content. So for instance, in that circumstance where you had that dry, hot air coming in, you were drying out the face. So you were shrinking the face, and so it was changing shape because the face was shrinking and the bottom wasn't shrinking at the same rate.
Gotcha.
Eventually,
Okay.
Eventually, if that solid piece had reached equilibrium through its entire thickness, it would have flattened out.
So I was right to blame my brother, no matter what you're saying.
Exactly. Yeah, no question. What are you leaving the stupid door open for? Especially
What's the matter with you?
With the Santa Ana winds coming through here, right?
Yes.
The happiest days of Wayne's brothers' lives was the day that he started to drive away. The last time, I just wish I was there when they were watching Wayne drive off into the sunset, and just a sigh of relief from Wayne's brothers. We got to do a show just with Wayne's brothers.
I'm not going to let that happen. So how do you sand the cup floor?
Well, yeah, you want to be sure that it's reached equilibrium. In other words, as long as the floor is at equilibrium when you sand it, and the conditions are the surface conditions for the life of the floor, sanding a cup floor shouldn't be an issue. Okay, so
I've always been under the assumption that if you sanded a cup floor that was still slightly moist, you didn't wait for it to get right, the equilibrium right. Would that cause crowning down the road?
Yeah, it would, because it's essentially when it returns to it. It may or may not, but I mean, typically the crowning is the return to its original shape. So if we look at the life of a floor, we put a piece of floor in, the floorboards are all fairly flat and straight. Then it picks up moisture on the underside, say dampness or water leak or something. If you were to just let that moisture go away and there were no permanent setting of the piece, which can happen. In other words, if it stays cupped for a long period of time, a lot of time that cupping becomes permanent regardless of the moisture content change. But let's say that it's instead of being permanent, it's what we would refer to as being elastic. So let's say that cupping is elastic. We remove the excessive moisture, returns to its original shape. But in the interim period, we've sanded the floor flat. And in the process of sanding the floor flat, we've sanded the edges down lower than the center of the board. And so that when it does return to its original shape, now the center of the board is going to be elevated above the edges, and then you get that crowning or convex surface on each individual board. Generally speaking, it's been my impression that most people don't even notice it. Whereas with a cup floor, everybody can see it, no matter how small it is. But crown floors, it's got to be pretty severely crowned before. And I've been on some floors that were really crowned, and nobody even noticed them. So you just
until you start sanding those things. That's one of the worst sand jobs out there.
Oh yeah, it's brutal. Yeah, you got to keep your teeth clenched so your fillings don't come out. You know.
Would it be if you did insurance work? Would it be prudent if you have a floor that cups to take your sander and lightly set it on light setting with 100 grit just to take some of that finish off to help that water dissipate, or does that help at all?
I think it might help. I think there are some pretty cool devices out there for drying wood floors these days. There's a mat that's made called an Inject-A-Dry that you tape to the surface of the floor, and then you put tubes on it, and it pulls a vacuum, and it actually will extract the moisture right out of the whole floor surface. It's amazing. Pretty cool thing.
Can you dry them out too quick?
Yeah, you can dry them out, not with that Inject-A-Dry. You can dry them out too quickly with heat.
Okay.
So, for instance, if you were to put a very high heat on a surface of a wood material, you would have the surface drying at a different rate than the interior of the board. And that's kind of what happens when lumber is being air dried, is that surface gets to ambient conditions almost immediately. And then the interior of the board is still saturated with moisture. So you get that checking and shrinking and that kind of thing that occurs. It's very difficult to cause checking in a floor after it's been kill dried on a job. I mean, you would have to have so much moisture in it over such a long period of time that essentially you'd basically have to rip the floor out because of the mold. I mean, there would have to be that kind of duration and magnitude of moisture condition.
So maybe we should switch gears then to concrete and installing floors over concrete subfloors. And actually, I know you've used our adhesive on your projects. I appreciate that.
It's a great adhesive. I'm actually in the middle of a job in Bermuda right now, which of course I can't do because they've stopped all flights into the airport, and they're under what is it called? Something in place, shelter in place.
Yes.
So,
well, gosh, when you get jobs like that, you know you're supposed to let me know so I can get an excuse to go over there and look at it.
So typically, I mean, there's a couple of approaches to concrete. One, you typically want to isolate the concrete from the wood floor. Okay? And so what we would normally do is use some type of moisture barrier. And where you're going to adhere to the concrete, you'd use some type of liquid applied moisture barrier. And where you're going to float over the concrete, you could use a liquid applied moisture barrier, or you can use some type of impermeable sheet goods, like a heavy polyethylene film.
Hey, Wayne, do we have anything like that?
We got the R540.
Yeah, there you go.
When you talk about it in the liquid, yep.
In fact, I had and the only reason I'm mentioning this because I just love talking about these really cool jobs I do because it makes me sound like I'm really a cool guy, and I'm really not a cool guy. But if you can't be cool, at least make people think you're cool. Okay.
There you go.
So
words to live by there, Wayne.
Yeah. So on this particular job, there were 4 cottages along with the main residence. And the cottages, we were going to adhere the subfloor to the concrete. So I put 2 layers of the 540 down. I rolled two coats of the 540 down, and then I took the plywood, ripped it into 2x8 sheets, and I stuck it down to the 540 with 851 R851.
Okay. Yep.
And used a very heavy spread on the trowel. Used quarter by quarter notch trowel. I think we're putting like 30, 35 feet to the gallon. And the subfloor is there forever. I don't want to be the guy that has to take subfloor out.
So that's interesting. You ripped it down the 2 foot by 8 foot sheets. And then what did you put over, a solid floor over top of that?
Yeah, there's going to be solid floor over the top of it.
Yeah. Okay.
And also what I do is when I do subfloor like that, I put the subfloor on 45-degree angle.
Okay.
That way, when they come in and tell me they want to change the direction of the subfloor, I don't have to get crazy. It's already good either way they want to run the flooring.
So with plywood, are you is that your preferred method? I mean, some guys will cut the sheets into 4x4 sheets, and I've seen guys use the entire sheets and curve the back of it. What would be your your go-to system?
Well, I think a 4x4 sheet is still really rigid. Okay. I mean, it's very stiff. And so by cutting it into something that's got a 2 foot dimension on it, I've got a piece that's reasonably flexible. I mean, it's not real flexible, but it's reasonable. And also you got to get the concrete flat too. You don't straighten out the subfloor with the adhesive or the plywood. The very first thing you do is you go in and get the subfloor as flat as you can get it, so that concrete is flat, so that when you put everything together, it lays flat. And so, and I also always leave a 1/4 to a 1/2 inch space between every sheet of plywood. I happen to use Advantech for all my subfloors, and the main reason I use Advantech is because it's flat. It's the stuff stays flat. It's not like plywood where you cut the bands on a pallet of plywood, and you got to jump back because the stuff is going to fly up in the air because it's so crooked.
You mentioned Advantech, and you also mentioned 540, and I don't know if a lot of our listeners know, but the bond with our adhesive on Advantech with 540 is incredible. It's a primer now on Advantech as well. And I just had a guy up in Michigan call me, and he had a herringbone floor that they changed the layout. He had to take some flooring out, and called me up and goes, "Oh my God, I cannot believe how well it holds when you put Advantech, or when you put the 540 down first." So we're really stoked about that.
It's a great mitigator for high moisture content in the subfloor. Yeah. And I think we started using that up here. Some of the guys that I do stuff with here in New England. I'm from the Boston area, so I know several of them started using it almost immediately on their builder work, so that they could get in there and do installs and not have to wait for the subfloor to dry. In other words, the subfloor was almost dry, but it wasn't quite dry enough. And so they go in and they put the 540, and they basically force it to dry from the underside. That's what they're doing. It's not meant to fix excessive moisture problems. I mean, that's not what all these moisture barriers are about. They're about getting you 2 or 3 weeks ahead on a job, and or eliminating the need to do some kind of special drying situation. Because the house is going to dry out whether you want it to or not, assuming that it doesn't have a continuous source of excessive moisture. You cannot stop the interior of a building from drying out. So it eventually will dry out. So what you want to do is create a situation where that excessive moisture doesn't affect the wood floor we're putting on top of it.
I mean, obviously they're building these houses so fast, man, and they're there's sometimes when they start digging, by the time they start digging and give the homeowner the key, it's like 45 days.
That's fast.
It seems like it puts a lots of stress on the environment in that house.
Part of that is not, it's not as bad as it used to be, because most of the builders today are using engineered framing products. So that those I joists and LVLs are all at 6 to 9%, unless they've been left outdoors somewhere. So
Gotcha.
it's not like the old days where you'd get 2x10s or 2x12s that were at 25%. So some of that is and essentially they're framing these houses so fast that if you unless you hit a real wet spell, a lot of times they get the houses under cover, and these advanced framing systems with the as long as you're doing wood framing with the zip walls where they put the tape, and I think other companies have a similar thing. They tape all the seams, so essentially the house is weather tight. And if they get the roof deck on fast enough, they even tape those things. And so it's not a lot of water gets on these subfloors like it used to. And especially when you're using something like Advantech, that stuff just, like a duck, it sheds water. So there again,
that's really interesting to me, Howard. There's some good things that have happened in construction over the years, and there's some things that are more challenging than in the old days. But that's something I had not considered. I mean, I just see the fact that they put these houses up so fast now. But you're saying the framing members and some of the other technology and going to Advantech actually work in our favor.
I think it does. I mean, it's leaving the building, partially framed with no roof on it for weeks and sometimes months. That is what saturates our subfloors.
And then you hear this is no matter where you are in the country, you hear everybody has the same challenge. You want to acclimate the wood, but the old argument is, well, they don't even have the HVAC on, and they can't get the permit or whatever. I can't move forward with my project until the flooring is done before they put the HVAC in, and so it's kind of a catch-22, and it leaves guys kind of in a tough spot. But acclimation has got to happen, right? I mean,
Yes, it does, and it's interesting. The state of Washington did an interesting thing. I think it was around 15 years ago. They required that the interior framing and interior part of the structure of a wood frame building had to be at or below 12% before you could insulate. And so they created this entire business where people would frame a house, close it in, doors and windows, and before they did any mechanicals or insulation, they would dry the interior of the frame out. And so if you happen to be lucky enough to work in that area, then you don't have to worry about the interior of the building.
I've always thought that the whole thing is backwards, to be honest with you. I mean, when the general contractor calls the flooring contractor in to do the work, the way that it should be is that house is conditioned for the floor guy. You know what I mean? That it's ready for the floor guy to do his job. And instead, the hardwood flooring industry and the contractor is almost too much of the onus is on him. I mean, we're giving an environment that in many cases isn't ready for us. And yet, if there's an issue, all the fingers are pointing your direction.
Well, the reality, Wayne, is that the onus is on. It's not on the industry. It's on the contractor. It's 100% on the contractor.
You talking about the GC or the flooring contractor?
The flooring contractor.
Yeah.
I mean, you look at our industry guidelines, and they make the poor flooring contractor responsible for everything in that house.
Yeah, I just have a problem with that.
Yeah, I had one since they changed it. Didn't used to be that way. Yeah. It changed about 12, 13 years ago. Used to be the industry standards, the guidelines said the house needs to be dry and so forth and so on, and didn't make the flooring contractor responsible for all that. the two critical elements to getting a floor to function properly are moisture content of the subfloor and fastening. And by fastening, bunch of nails and glue assist with the wider boards on a wooden subfloor. And if you're direct gluing, don't skimp on the glue.
Yeah. You know, we talk about in this industry, we're going wider and wider. And unfortunately, the wider the board, the less fasteners per square foot. So that's where the glue assist is almost becomes, I mean, really proper protocol anymore.
And the end matching is so loose. It always has been. I mean, it's been that way since the beginning. I mean, the end match has been loose since they started end matching, because the installers can't take a tight end match. You can't get the boards together. So really, on wide boards, you got to glue the ends. You got to put a dab of glue under each end. Otherwise, the machine's going to hop on you, and then you're going to get that crazy, wacky, what do we call that? The wave.
Wave
the wave, and Lord knows what else. I mean, you can feel it when you're running the big machine. That back wheel hops on those things.
Yeah, that's a real good call, Howard. Those whiteboards on the ends, it's got to be glued. If nothing else, I mean, the very least, I couldn't agree more. I've seen it cause a lot of heartaches, and a lot of times you don't see it until that first coat of finish goes on, and then it's all the time. That's when we break out the traffic extra mat.
Filter mat. like the -4 gloss, right?
Yes. That's when you go, you know what would look good on this floor? The extra mat would look really, really nice on this floor.
Just disappears. It looks so natural.
Yeah.
And we don't usually move furniture, but you know what? We'll give you a hand moving the furniture too.
And the rugs. We'll put the rugs down.
Yeah. Howard, it's been a real education. Like I said, there's so many different ways to go with you because you've done so much in this industry and you have such a vast knowledge that I hope we can have you back and talk about some more things down the road.
Well, that's I'm just thrilled at all just to get the opportunity to chat with you guys on the phone is just really a pleasure. It makes my week that I got to spend an hour with Rob and Wayne. I got to tell you. So it's too bad we're so far apart that we don't get a chance to see one another. But it's nice to get the opportunity to spend some time with you. And I have to say, Bona has your guys in New York City have been phenomenal. I mean, Jeff, Frank. I spend most of my time with Jeff, but I mean, they just do. They're good people. The support I get on my big projects. I mean, I can't tell you how helpful they are. I mean, they make my life. They make my life easier, and they help my customers a lot, and it's just great stuff.
Yeah, appreciate to hear that, Howard. I'll leave you with just this then. We're in the middle of this the COVID-19 thing, and as long as you've been in the industry, and as long as you've been in the trade, and you've seen a lot in your career and your life, and what would you tell contractors now that they're being, having to sit and not work, and do you have any advice, or how are you going to look at this?
This is my approach to it, and I kind of got this approach from my son, and because he used to work with me a little bit in between going to college and becoming a physical therapist, and so he one time made a remark when we were walking away from a job I went to look at, and he says, "Dad, what are these people so upset about? It's just a floor, okay?" And so, it's not like we're brain surgeons or we're EMS. It's not like we're in an emergency situation. We're doing floors. we're getting this really wonderful break right now. I mean, think about it. I mean, we get to spend times at home with our family. We get to spend time reading and doing some research and maybe catching up on our paperwork and maybe sitting around and just thinking. And so take advantage of it. This isn't going to last forever. It's going to be over before we know it. And then we all get back to work and we get busy again, and the next 30, 40 years go by, you know? And they go quick. Savor the moment. This is the good old days. Stay home, stay healthy. You know, do the stuff it takes to keep yourself from getting sick. Like I said, it's just a floor. Don't get sick over it. Don't endanger your family to do a floor.
Wise words. I really appreciate that. And I kind of had the same conversation with my two brothers that just got shut down in California now. You guys work so hard in this trade, man, so hard, and so many hours. And hopefully you guys can just take a little downtime here. Because like you said, I think this is going to be gone before we know it. And we're going to be pissed off at the painters again, just like we always are. And you know, we'll be back up to 90 miles an hour again. So I hope guys can be able to take that approach. Some people can't afford to. I recognize that, but certainly hope that everybody can. Howard, thanks again. Really a privilege, and would love to have you back on down the road. And thanks again, and stay safe, and thanks for all your knowledge. And again, where can people get a hold of any information by you? And you do consulting as well, so if there's a way guys can get a hold of you, throw it out there.
Yeah, if you want to call me, you can look me up at brickmanconsulting.com, and you can call my office 781-659-7209, and I'm happy to talk to anybody, probably longer than you want to. You'll have trouble getting off the phone with me, and but no, I'm happy to help if I can. I over a period of a week, I probably talked to 5 or 6 people, and I kind of like being helpful, and I would prefer that you don't have to hire me as a consultant, because that just means you've got, you know, problems that are really kind of yucky. But if you have those, I try to be helpful too. So.
Thank you, sir. All right.
Great.
All right.
Well,
Thanks, Howard.
Thank you for including me
sir.
in on this thing. Really wonderful. You two guys are two of the special guys in the business. Bona is lucky to have you two, and like I said, they've got a long bench at Bona, and you really do it. There's just not another company that I know of in the wood floor business that contributes as much to the trade as you guys do. I mean it's and consistently has over the years. And like I said, if anything, I hope that your people that own and manage your company keep up the good work, because you've got the right people, and you're doing a hell of a job.
That's awesome. I'm glad to hear you say that. So thank you, sir.
You're welcome.
That was good stuff, Rob. I could see why you'd want to run Howard Brickman again. I mean, everything the guy says, I mean, you really want to dissect it, because he I mean, I don't know if he is a scientist, but he is. I mean, thank God we have a guy like that in the industry, right?
He's one of the interviews that we did that you really want to take notes. You want to play this over, listen to it the first time, and then go through the second time and take notes, because there's just so much great information that he has.
A lot of our shows, in fact, they're all saved. I mean, you know, if you go to Spotify, or a lot of them now are on YouTube. If you go back to, if you want to know something about a certain topic, you can go back and revisit that topic, and there might be some information you can gather from that. But yeah, good stuff, man. I really like Howard Brickman, and got a lot out of that. So this has been another episode of On the Floor with Wayne and Rob. Please stay tuned for another episode.